Welcome to the 2021 On-Farm Network Results Series. I'm Megan Burns, agronomist for the On-Farm Network program. This short video contains some important information on what to expect from the Results Series videos and tips to interpret some of the trial information. So we started the Results Series last year in response to being unable to meet in person, and these videos were quite well received. So we decided to give this another go for the 2021 season. So these videos are meant to be a quick overview of the highlights. You'll notice that they're quite short in length, and you can find a video for each of the main trial types that we had this year in the On-Farm Network program. So you can kind of pick and choose which ones you might be interested in, depending on what you have on the go on your farm. In each video, we talk about agronomic and economic results, as well as overall takeaway messages from the season. And new this year, we've also added an Across the Network section, where we kind of put the 2021 trial results in the context of the larger results that we have across all 10 years of the On-Farm Network program so far. We had a couple of new trial types this year and some really interesting results in some of our dry bean trials. So those are a couple of the things that you can look forward to in these videos. If you aren't familiar, the On-Farm Network is MPSG's in-house research program. So we run field scale research on farm with farmers. And as you can see in this animated map here, our program has really expanded in trial number and geographic reach over the last 10 years. So in total, we've now conducted more than 400 trials. So we're really building up quite a large data set across time and space. For the 2021 season specifically, we harvested a total of 54 trials across 4 crop types and about 16 different types of questions or trial types. And some of those were sort of preliminary years of testing out new trial types or questions. So you won't find all 16 trial types in videos this year, but there are certainly 10 or 12 for you to explore. So very briefly, just to make sure that we're all on the same page, I just want to run through a quick statistics brief, starting with why statistics are important in the first place. So statistics tell us if the differences that we get between treatments are real and if they're a result of our treatments that we were testing, or if they are simply random and the result of background variability in the field. Now, if you imagine this NDVI image here as being your field, and you were to go out and take 8 combine passes consecutively across the field, we would expect to get 8 different yields from those 8 combine passes, simply because we know there's inherent variability in our farm fields. What statistics give us the power to do is investigate why those 8 passes with 8 different yields are actually different. And to be able to run statistics, we need to make sure that our trials are properly set up with replication and randomization, both of which are built into all of our trial protocols to make sure that we can run these stats. So that's why statistics are important, because they tell us if our treatment really made a difference. So we present our yield data as an average for each of the treatments. So you can see just 2 bars on this graph. So we present overall averages for each treatment in a trial type. And our statistical outcomes are shown as letters above the bars. Now, the letters indicate whether the average yields of each treatment within a trial are statistically the same or if they are different. So if the letters above the bars are the same, as in this case where we have 2 A's here, there's no statistically significant difference in yield. This means that the averages of the 2 treatment yields may be numerically different. So we can see a difference in the height of the bars in this graph here. But that numerical difference is simply from random variability in the field, not an outcome of the treatment of your trial. So remember that 8 passes through the field, 8 different yields kind of concept. We expect some variability to occur naturally, and we need our stats to tell us if this difference that we see numerically in the height of the bars is real and a result of our treatment or not. So in the case where the letters above the bars are the same, you'll see 2 A's, and that means there's no statistically significant effect of the treatment on yield. On the other hand, in the case where we have letters above the bars that are different, there is a statistically significant difference, and that difference is a result of our treatment. So that's the case in the bottom graph here, where we have a B and an A. So that means that our treatment, which in this example is a fungicide application, is having an effect on yields, and it is different between the 2 treatments in the trial. So in addition to the yield graphs, you'll also see accompanying tables that have some important yield and statistics information in them. So there's 2 things I want to draw your attention to. First of all, we have the p-value. The p-value is an output from our statistics procedures, and that is the value that tells us whether or not we have a statistically significant difference. So all you need to know to interpret this is if the p-value is greater than 0.05, there's no significant difference, and you're going to find the same letters above the bars in the graph. On the other hand, if the p-value is less than 0.05, that means there is a statistically significant difference between the treatments, and you're going to find different letters above the bars. To keep things really simple, we also have a significant statement right in the table to tell you yes or no, this is significant or not. The other value that is in these tables that's important to understand is the CV value. Now, CV is the coefficient of variation, and basically it's a measure of how variable our data is. So the higher the CV value is, the more variability you have just kind of inherently in your trial. And really high CVs or really high background variability for one reason or another can be a problem because it can kind of mask any potential treatment difference or treatment effects that might be there if your kind of background variability was a little bit lower. But luckily with our trial protocols and setup, we're usually very effective at keeping our CVs quite low. So anything kind of under 10% is pretty normal for us. But if we, for some reason, get data back that has a CV of kind of anything over 15%, that's a case where we investigate that a little bit further and see, where's that variability coming from, and is this still valuable data in terms of determining treatment purposes. So yeah, that's kind of all you need to know for interpreting the graphs and the statistics tables. Again, like I said, we keep things pretty simple with a significant statement built right into those tables there. So now that we're all up to speed on that, I quickly want to go over our economics results. So our economics are intended to be very simple in their assessment of outcomes, using values that would apply to sort of most operations. So your specific costs and market prices are obviously going to differ from the numbers that we have here, but we've selected values we feel are sort of average and most stable over time as much as these economics values can be. So most of these values are from the Manitoba Ag Cost of Production Guidelines, but they're also developed over discussion with farmers and agronomists to reach sort of that overall average idea that would be most applicable to most operations in most years. So in the results tables, there are columns representing the cost of the product or the management practice that we're testing, and then also a change in profit, column as well. So obviously, as far as a change in profit goes, there are two different situations depending on whether or not our treatment had a significant effect. So in the first case here, what we're looking at is the example where there was no significant difference between our yields with our treatment. Now, in this case, the change in profit per acre is simply a straight loss equivalent to the cost of that management practice or that product. So we're keeping it very simple, just that you're not getting any return on investment, so to speak, in that management practice if you're not having a significant yield effect. And as a result, the cost of that practice is simply a straight loss in profit per acre. Now, on the other hand, when there is a significant response, so the treatment is having an effect on yield, our change in profit per acre takes into account the change in cost per acre using the product, so your input cost difference, and it takes into account the change in yield as a result of that product use. And then we show our change in profit per acre across a range of market price. So you'll see a range in values when you have a significant yield difference. So again, your specific costs and the market price that you get may differ, but these economic tables are meant to kind of act as a gauge or a guide for interpretation of the results. Obviously, all economics should be considered on a farm by farm and a year by year basis, but this at least gives you a starting point for kind of a general economic overview of the results. And then something new this year that you'll notice in some cases where there is a statistically significant yield difference, we've actually gone a step further and broken down our costs and our change in profit per acre to be reflective of sort of those long-term average conditions, like what's most applicable in most years to most farms, what I was talking about earlier. But we've also added a current conditions column in some cases, because we recognize that obviously 2021 prices are a little bit wild relative to normal. And we wanted to enable, pretty quick and easy interpretation of what's going on this year, but also kind of what this might look like if we get this type of yield response in a different year where we're more normal in terms of prices and costs of production. So that should be all the intro information you need to enjoy these results videos. As always, if you have any questions about specific results, interpretation, if you're interested in getting involved, or if you have a trial idea, please reach out to the On-Farm team via phone or email anytime. A big thank you to all of our On-Farm Network participants. We look forward to more successful seasons with you in the future.